Traditional water quality modeling frameworks often overlook the dynamic interactions between multiple factors that influence spatiotemporal sediment yields. This study aims to bridge that gap by integrating remote sensing data from satellites and hydrological modeling to assess these interactions at the basin scale for a more accurate prediction of sediment yields in watersheds. We developed a connective algorithm to simulate spatiotemporal sediment yields in SWAT by incorporating two models of the crop and cover management factor, known as the C factor, and the soil erodibility factor, known as the K factor. The novel functions of the C factor and K factor, which were developed using spatiotemporally dynamic satellite remote sensing data, are expected to tackle the uncertainties in sediment yield predictions. The developed algorithm was validated using a sensitivity analysis of sediment yield predictions in 3 different cases. Our results showed that the model efficiency of sediment yield predictions increased for every dynamic factor added. For all cases, the highest model efficiency occurred when the 2 dynamic factors were connected. 2 basins, the Tampa Bay watershed in Florida and the Winyah Bay watershed in South Carolina, were used in this study. C factors were found to increase in lower Tampa Bay, indicating the presence of deforestation as well as land management activities in the lower Tampa Bay region. The distribution of KUSLE for the lower and middle Tampa Bay watershed was underestimated in comparison with the developed annual K factors by 45% and 35% respectively. Only 20% of the total watershed area showed K factors between 0 and 0.1, which leaves a significant portion of the Winyah Bay watershed with moderate or highly erodible soils. Hence, it is necessary to adopt sustainable water management measures as well as erosion control strategies within or near the coastal zone for the further improvement of agricultural productivity. With variable spatial resolution and relatively coarse temporal resolution satellite remote sensing data, a good estimate of sediment yields in catchments of the southeastern United States can be made. The spatial variability of sediment generation in the hydrologic response units of both watersheds was much more significant than the temporal variations. Therefore, the temporal variability of the K factor, which represents the severity of soil and sediment loss, is less dominant when compared to its spatial variation.